This is our first example. We have an inequality statement right here. And this particular section is section 2 in unit 3, which is our chapter 2. I don't know. Anyway, it all has to do with inequalities. And in this section, you can see that we have an inequality instead of an equal sign. It's very similar to solving an equation. If it says solve for x, that's what we want to do in this particular situation right here. We want to try to get x all by itself on one side of the inequality. So the two sides of our inequality are sort of separated just like we did with our equal sign. We want to separate two sides, right, like this. And then we want to be able to try to get rid of, this particular section has just some simple ones to start out, adding and subtracting. And if there's only adding and subtracting, then all you do is solve it just like as if this was an equal sign. Okay, so there's two sides of the inequality, right, like this. And then we're going to subtract. Well, this is already subtract. So we're going to do the opposite of subtracting 5, which is add 5 to both sides, right, like that. Draw a line under it, right, like that. And then we cross these out. Because these go away, minus 5 and add 5 will turn into 0. And we drop down our x. We keep our inequality facing the same way if all we did was add or subtract. Okay? There is this rule in the next section that says if you were to multiply or divide by a negative number, then you would take that inequality and flip it around. That'll be in the next section, not this one. All right? So we keep the inequality facing the same way. Do this arithmetic right here, and it turns out to be 2. And look at that. Our variable is all by itself on one side. So finally, our final answer is x is less than 2 is how we would say that. So that means that our solution is any number that is smaller than 2. Not including 2, but any number that is smaller than 2 right there. All right. So check. It does work. You could actually check your solution to see if it works by plugging it back into the original. Here's my original. And I can plug that back in, and I could put it right here, 2 minus 5. And I ask myself, does that make it a true statement? Does it actually, it says 2 minus 5 would be negative 3. And, wait. 2 minus 5, negative 3. Okay, and if I was to go graph it, it says right here, graph the solution, right? If I was to graph it, I make a straight line like this. Sometimes the graph is given to you with, like, say, a number in the middle, and then sometimes you need to go and graph it yourself, all right, and make your own line. No big deal either way. Okay, I graphed this piece right here, so I would write a 2. You could put your other numbers on there if you want, but you don't have to. But the way number lines have to work is they go by the same amount every time. Try to get your spacing consistent. Okay, and then there's two things to remember. If I have inequalities that look like this or like this, then it's going to have an open circle on it. An open circle means it does not include that number. Okay, if it's like this with an equal to underneath, or like this with an equal to underneath, then we fill the circle in, which tells all the readers of that graph that it is included. Okay, so in this one right here, it is an open circle. Okay, some people do it above the graph. I like to do it right on top of the actual number line. And so I graph it right like this, open circle. And I ask myself, I read it, x is less than, pointy part is less, open part with the alligator mouth is greater. So it is less than 2. All right. If it's less than 2, it's all the numbers that are smaller than 2. So we end up shading it right like this. Make it kind of dark. Make sure you shade it, and sort of like that. All right.